Good morning. This is Tim Stewart. I am president at Visual Decisions, and we're here today to talk about improving the operator experience at work, really, utilizing Industry 4.0 solutions. Just as an introduction, where we started the operator experience at the beginning of last century was similar to what you see here with Taylorism in scientific management. And in the subtitle, I put that it was an early attempt to put robots in the plant before robots existed. The idea with this was to break everything down into the smallest possible step and just, automate the heck out of, people's tasks. And, the concept of standard work wasn't yet what it is underneath the Toyota production system, but, the idea was that people would perform the same task over and over again. And as you can see, they didn't have a lot of feedback to them other than, what they could touch with their hands and so forth, and whatever the managers would yell at them. So lean manufacturing really changed everything. And I won't get into the details of lean or the Toyota production system or anything else, but I'll focus on this quote from Taiichi Ohno, where he said that the real objective of the Toyota production system is to create thinking people. And, if we kind of start from there, where we were at with that picture on the last page, those were not thinking people. They were automatons that, were highly dexterous. And, the idea with lean was that you really wanted you wanted to push decision making as far down in the organization as you could, ideally to the operators themselves. And, the problem with that was that, under a lot of, manufacturing practices, the operators didn't really get visibility beyond their machine. And so how do you make good decisions when you don't understand the overall context? I did a presentation earlier this year on augmented operators. And a quick definition of that was, combining human-centered design, including, lean practices and everything else, along with supporting them through the Industry 4.0 solutions. And, in terms of those solutions, what technologies are available today to help them out? Well, one of them is IIoT, or the Industrial Internet of Things. And it's, that's connecting up to the machines, being able to collect information from those, put that into human understandable format, putting the visual controls out onto the factory floor, and, really helping to automate that process of collecting data, displaying it, and taking action upon it. The next one is augmented reality. And as we look at augmented reality solutions, I'll touch on those throughout the presentation today because they have a tremendous leverage for helping the experience of the operator in a number of different ways. Business intelligence solutions, such as Power BI or Tableau or Click or any of the other ones out there, can do a lot in terms of dashboarding, in terms of reporting. So, being able to collect information from a lot of different data sources and bring that together to put information into one context that you can then display in a very flexible manner to anyone in the organization and, wherever they are in the world and so forth. And then, artificial intelligence and machine learning to not only help automate the process of data collection and so forth, but help to automate that process of data analysis and being able to, help augment the decision making that needs to be done as well. So with that, let's go through some of the different use cases that exist out on the shop floor. Certainly, training, digital work instructions, standard work support. I'll kind of group those three together because they kind of overlap in terms of a lot of the things that you're putting in place. The training, you want to utilize the work instructions to help with the training and so forth, so that They're learning the proper way to do it and so forth. Standard work certainly incorporates those work instructions and so forth. And so, all three of those tie fairly tightly together. Autonomous maintenance and, pushing that responsibility for the behavior and functioning of the machine, as low as you can within the organization as well. So that the operator can perform as many of those routine maintenance tasks as possible, but then giving them the information and so forth that they need to be able to do that. Looking at the visual controls that I mentioned earlier, and how do you modernize those utilizing some of these different solutions. Quality monitoring, setups and changeover optimization, some of that automation and decision support. And lastly, but not lastly in real life, is safety. And what are the safety impacts of a lot of these different things? So with that, let me start at the top and go to training. And when we look at training and being able to either onboard new employees or to be able to cross-train your people and so forth, move them to new positions, all of those different things. This can have a very large impact on the organization, especially in the current environment where we have an aging workforce. We're trying to bring new people into the organization. A lot of the people that we're trying to bring into the organization may be millennials or Generation Z people that have done a lot of their learning either informally or over web or video or et cetera. And some of the older training methods that organizations have may not be appealing. And so one of the things that organizations struggle with is churn within their new employee base, and being able to get them trained adequately and have that delivered in a way that feels modern to this modern workforce is certainly an advantage in terms of being able to not only recruit but also retain those people. In terms of some of the advantages of this, certainly when you can utilize things like augmented reality within that training, first of all, you can accelerate the time of the training itself. You can reduce the cost significantly for travel. If you're training on particular equipment and so forth, you might be able to do that without having to put the operator at the equipment itself, so that you can train them without taking that machine out of production and so forth. You can reduce the number of specialists that you have to take out of the process in order to do that training as well, because now you're able to do that training with that augmented reality solution, instead of taking an expert and having them shadow that person that's trying to get up to speed on the process and so forth. And in terms of being able to capture some of the expertise of the people that are out there today but may be leaving because of retirement fairly soon, or if you're a growing organization and you simply need to scale effectively, then having the ability to have your people wear some of the real world glasses or something along those lines to capture what they're doing as they do the process, and then create those work instructions based upon how do your most expert people actually run that process. And so being able to do that knowledge capture and knowledge transfer is one of the real key benefits of an augmented reality solution within manufacturing. Speaking of creating those work instructions and so forth, once you have those captured, there are a number of different ways to deploy those to your workforce. Certainly, you could print them all off and create a paper manual, but why would you want to do that these days? if you have a display, out at the work process itself, you can display not only the work instructions and, have any downloads that are required in order to give more detail. You can track, the steps as they're performing them, and then you can have reporting against that and so forth. You can do quality checks and inspections and so forth right with the work instructions, so that not only do they have the instructions in front of them, but any of the information that you want to capture is prompted, and you can ensure that you are getting the information that you need. Just as one quick example, I've been working with a company lately that when we started to engage with them, had a literal 0% first pass yield at final assembly. And the biggest single problem that they had was that, labels were either, put in the wrong place, oriented incorrectly, or, missing. Things would be painted the wrong color. These were, fairly complex machines that, had a lot of different subassemblies that came together at final assembly. And, being able to just track for whatever they're working on, what are the actual work instructions, and being able to have those quality checks built into those work instructions and the data collection is a magnificent boon for them in terms of being able to radically improve their performance in final assembly, which not only helped with the quality and rework costs, but actually significantly boosts the throughput of the organization as well. And certainly if you're utilizing those glasses to capture the work instructions and so forth, or even if you're just creating those work instructions in more of a studio kind of a fashion, being able to put those work instructions out there with the glasses to be able to see the process, see the machine itself, and then being able to see the work instructions right there means that I can focus on the work without having to, turn my head, turn my body to look at a computer screen or a printed manual and, look at those instructions and then come back, reorient myself, in front of the work process and now perform the task. By utilizing augmented reality techniques, you can actually have those work instructions overlaid right on the equipment itself so that you can stay in context that entire time. And then in terms of standard work, the idea of being able to deliver the right information at the right place at the right time, and helping people understand, at all times, what is the work that they're supposed to be performing and how are they supposed to be performing it, is certainly extremely helpful, as we've been discussing. But then, being able to also just encourage the adoption of these new and standardized work practices, because you have these augmentations, is something that is extremely valuable to the organization. And then also the ability to detect and elevate attention to those deviations from standards so that they can be mitigated, as rapidly as possible, is another advantage. So in terms of autonomous maintenance, and again, the idea is that you want to push these things down as far in the organization as you can, and have the people that are interacting with the machine, every single day, really own the responsibility of maintaining that equipment and keeping it running efficiently. But your operator's main task is to produce parts, so you don't want to train them as a maintenance person. So how do you give them the information that they need to know? When should they be performing what tasks, and how do they actually do it? Well, that's a lot of the things that we've been talking about in terms of work instructions for producing parts. You can also apply that same type of capability to the autonomous maintenance. So in terms of the work instructions and being able to see what needs to be done and so forth, certainly you have the capability of as you see on the screen here, putting that right on somebody's phone, a iPad or something along those lines, so that they can look at the machine and see how to perform those tasks. But then also being able to prompt the user by tracking automatically, if you're supposed to do this maintenance, every 3 months, being able to prompt them that, hey, it's time. If it's supposed to be done every 10,000 parts or whatever, you can do that. Because the system knows exactly, how many pieces are being produced, what's the actual, runtime of the machine and so forth, as well as that maintenance schedule. When the operator starts their shift, they can see a list of, what are the tasks for that day outside of production that they need to perform in order to keep the machine running as effectively as possible. Visual controls. If you've been with me on other webinars, you'll know that this is a topic that I feel quite strongly about. The time for manual controls, that have been in place for years and years now, have done their job. I mean, they've significantly improved performance. They've helped people understand the context that they're performing within. They give information, give feedback, create those loops and so forth. But there are some problems with manual controls. First of all, there's a lot of waste in terms of rework. Somebody typing something or writing something on a page, somebody else coming by, typing that into Excel, somebody else taking that Excel spreadsheet and combining with other information and so forth. So there's a lot of rework in that process, movement in terms of people having to walk to a central board to write their information down. Certainly, it's an error-prone process in terms of having missing data or incorrect data, transcription errors, etc. If you're in a high-volume environment, just being able to keep up with the pace and so forth is a tremendous challenge. And then, from some limitations perspective, it's only viewable in one place. You don't have built-in history or persistence of that information. It lacks detail, it lacks context, etc. And so if you think about visual controls and how these were looked at in the past in terms of automating those boards and so forth, whether it's a TPM board or just how many have I built today, a paste board, etc. David Mann has a great book, Creating a Lean Culture, that I've utilized very often in terms of how do you actually instill these work practices within your workforce. But where I do have disagreement with him is when he created that book in the early 2000s, I think that he was looking at ERP systems that didn't collect a lot of that detailed information, that were highly inflexible. The reporting was not great. And it doesn't really account for what you can do with Industry 4.0 solutions, such as IIoT. And so I've gone through, I've done this. If you're interested in detail behind this, first of all, I have another webinar on visual controls. But in addition, you can download this presentation from my website afterwards and go through all the details of this page and this page. And read through how I think that this has changed over time. The biggest complaint I get about automating that process is that you lose the fingerprints on the data, so to speak. You lose that connection with the operators and the sense of ownership of that information. So what I will say is that that's all based on the standard work that you put around this. Just having people write down a number on a paste board doesn't really give them a lot of ownership. It just gives them busy work and helps their step count on their Fitbit. You can actually have much greater involvement if you automate that boring stuff and you put standard work around utilizing that information to actually improve the process. And that can create much deeper understanding, more lasting ownership, because you are facilitating much broader and higher, richer context around the data. You can visualize many more possibilities for improvement than, if you're just writing a number on a pasteboard. And then also, the investment in change, because you're giving them this additional information, because you are involving them in actually fixing the problem as opposed to just collecting the data, then I think that you can also get them much more invested in the change itself. So quality monitoring is another, big benefit, of these solutions for the operators. In terms of, the kind of internal cost of quality, from a cost of poor quality perspective, being able to detect and reduce, different sources of variation, whether that's from the machine, from the operator themselves, or any other source, can certainly help reduce that cost of quality. But depending on the operator to manually make inspections, manually record the information, do the math that's associated with like a statistical process control process, it adds a lot of overhead. And again, if you're in a high volume environment, it can be very problematic. And it also limits you just to the measurable, easily measurable for the operator output variables, on the process. Whereas if you automate that, now you have a world of additional possibilities in terms of different, aspects of things that you can do. You eliminate the math from that process for the operator. So again, they can focus on understanding what to do with that information as opposed to just how to collect it in the first place. And then in terms of cost of good quality, these solutions give you enormous opportunities to take the burden off of the operators to do the testing, inspection, et cetera, by putting additional automated tests in place, vision systems, et cetera, so that you can reduce that manual inspection and manual testing, and also eliminate duplicative testing across your different processes and so forth. Another example from a quality perspective is, eliminating the errors before they happen with things like vision picking, where you either have the glasses with this overlay, or even without the glasses, you can simply highlight which bin they're supposed to pick parts from with a simple LED or something along those lines. Of I understand what part is at the process. I understand what bill of materials is for that operation. And so I'm going to highlight the bins just with a simple LED that the operator needs to pick from. Or you can go fancy like this and have them actually, connected to one of these systems that not only tells them which bin to pick from, but also understands, since they're wearing the item on their wrist, exactly which bin they did pick from, so that you can track whether they were pulling from the right place or not. In terms of setups and changeovers, again, the work instructions play a big part here. Being able to monitor things as it happens and being able to track, automatically deviations from that standard. Being able to put something as simple as a countdown clock in place that understands when that changeover started, what the expected time is for that setup, and being able to give them feedback in terms of where they're at. But then also much more advanced things in terms of understanding where they're at on their last work order, notifying any material handling people that you have out there in order to kit whatever they need for the next setup and deliver that to that workstation so that the operator doesn't have to leave. Being able to do comparative analysis between different operators, different products, et cetera, having all of that information to perform the analysis. And then some of the really advanced things is that you have video systems out there these days that are able to track movements for individuals and so forth. And you can actually start to do your spaghetti mapping automatically using either those video systems or something a little bit more basic like an RFID tag or something along those lines, so that you can look and see what is the movement that the operator is performing as they go through the process of doing the setup. And now you can start to optimize how that actually happens. I've talked about a number of different forms of automation already, but I'll cover one here that I did on a webinar a couple of weeks ago. In terms of being able to respond when the machine has a problem. So, when the failure occurs, what has to happen in order for that machine to get fixed? Well, first of all, the operator has to be aware that the machine has stopped. And if you've got a complex environment, the operator is either at several different workstations, or they're operating a long line, and they're doing materials and everything else along that line the whole time. They may not initially be aware that, hey, if I'm standing at the packaging machine, I don't know for a little while maybe that the filler has stopped. And so I have to, first of all, be aware that there's a problem. The second thing is that the operator has to be able to do some level of diagnosis of, is this a problem that I can fix? What is the nature of what happened? So whether it's something as simple as a jam, or if there's an electrical problem with the machine itself, they have to be able to do some level of triage to be able to determine, is this something that they can address? And certainly, if an IoT system, for example, with machine learning is tied to the machine, being able to pull information from that, and then automatically categorize the type of failure based on the information coming from the machine, whether that's fault codes, whether that's looking at process variables, such as the power draw, the heat, vibration, etc. You can start to automatically determine what type of failure this is, and so forth, and whether the operator can do that job themselves, or if they need help from maintenance or engineering. And then integrating the system into your maintenance management system or ticketing system, or whatever else you have. And then being able to work outside of that as well, to not only create a ticket for maintenance with all of the information that you've collected from the system, so that maintenance understands this problem better. But if you know that based on the classification of this problem, you're going to need engineering support as well, you can automatically alert those people through email, text message, etc., that this is something that they're going to need to get involved in as well. In terms of maintenance, assigning somebody to this, I've been in an awful lot of plants where essentially you don't have any information about what the nature of the problem was as maintenance. You're off in a different area, maybe even a different building, and you get a work request that the machine is down. So you don't know whether you need to send a specialist in electrical, mechanical, or anything else. And so you send somebody out to the problem, and then let them do that diagnosis. But if you can automate that process, certainly that can happen a lot faster. You have to wait for that worker to become available. They have to travel to the machine. Maintenance arrives. Again, diagnosing the issue. And again, if you have that automated process of being able to diagnose that problem, you can radically reduce the amount of time that takes. Oops, wrong button. And then in terms of fixing the issue, if you have seen this issue before and you captured what needs to be done to address this, you can have those work instructions available so that your maintenance person can get the machine up and running as quickly as possible, or ideally that you can give those instructions to the operator themselves and they can make the fix, or get remote support so that they can just point their phone at it, have a conversation somewhat like FaceTime, but augmented FaceTime, if you will, and be able to get that assistance to get the process back up and running, and avoid having to have somebody come back out a second time in order to fix that process. And so that's just one example where you can see various pieces of automation in place that help not only prevent problems from happening in the first place, but to radically reduce the average time to repair. From a decision support process, certainly applying machine learning, artificial intelligence to a lot of problems on the shop floor. There's a ton of different examples there. And again, I've had another webinar on that, but I'll give one example from a customer here. They utilize a lot of grinding. They make metal parts, and so they do a lot of grinding in their operations. What they're really interested in is being able to, first of all, understand the life of that grinding wheel and maximize it so that they can minimize their tooling spend in terms of having to buy new wheels or refurbish existing ones, and just maximize the life of each wheel. But then they also want to make sure that they don't produce any bad parts, because they don't necessarily test for the output of that process for several operations downstream. And if they're producing bad parts, they could produce their high volume operation, they could produce 1,000 bad parts before they ever find out that that first bad part that they produced finally hits test downstream. And so it's very important to them to be able to automate this process and really help the operator decide when that grinding wheel needs to be changed. So what we've done is we've built a model for them where we're collecting information about the power draw on the spindle, the vibration, the noise, et cetera. And you pull that into a machine learning model to be able to identify when that grinding wheel has really reached its end of life, not just, hey, we're going to grind 10,000 parts with this and then, we're going to change it out. But, for that particular grinding wheel, when is it, at its end of useful life? And then we can deliver that information to the operator on computer or tablet, on, mobile, AR, whatever it would be, to let them know that it's time to do that change. And then finally, from a safety perspective, there's a lot of things here in terms of, if you've done an FMEA on the process and you see that there are safety, risks associated with the equipment, being able to, detect when those failure modes are about to occur is something that can, help, the safety of that process. Being able to predict certainly when those failures are going to occur is going to significantly improve the safety of operating that process, but also just from an environmental safety perspective. I've worked with a company that produced explosive material, and being able to detect whether there was a proper vacuum in the machine, so that as the material was injected into the operating chamber, if there was any oxygen present, it created a fail-safe so that that material wouldn't be exposed to that, because as soon as that material would hit oxygen, you would have combustion. And they actually had an accident where the building, unfortunately, had a significant fire incident because of that. But being able to put these checks and safety things in place, can prevent those problems from happening because you have those fail safes. And being able to look at overall environmental safety in terms of environmental monitoring, looking at heat, humidity, and the ambient area and so forth. Being able to look at things like robot-human interaction and making sure that you have a safe working environment and you don't have those issues taking place. All the way through, a lot of the things that we talked about with work instructions or standard work, those instructions are in place, not only from the process of producing good product, but also keeping the environment safe for the operators. How do you do this process, not only to produce good parts, but also in a safe manner? and being able to give those work instructions to people, again, within that context, so that they're not having to switch context to see those work instructions, being able to detect any deviations from that, being able to automatically, either set the settings on the machine, automatically, or being able to detect if they're not set correctly, and being able to, put fail safes in place so that the machine isn't run without those, just creates a much safer working environment for your people, so that they can focus on producing parts, and having that burden of doing it safely somewhat lessened, because they get those signals when something is not safe in the environment. You always want to still preach that they need to be aware, they need to be their own fail-safe and so forth, but having those additional checks and that additional monitoring in place certainly can help make that happen. With that, I want to thank you. I don't see any questions in the Q&A, but I will probably reach out to you and follow up to see, if this is something that is of interest to you and your organizations. But feel free to reach out to me first. You have my email and my phone number there. Within the next day or two, I'll have this presentation up on my website, and there will be a PDF copy of the presentation to download as well. So thank you very much, and I look forward to seeing you again next week. Bye.